Good afternoon. My name is Rishi Chugh and I lead the product marketing for the ThunderX product line at Cavium. And today I'll give you a brief overview and details about OCP based ARM servers and what Cavium has in terms of offerings for the next generation cloud-based servers. So from a corporate point of view, Cavium is basically a big iron company, well established. Started off in 2001 and we are very profitable and we are addressing the emerging needs of the industry, specifically for the data center and cloud. Where we have our footprint is basically in the enterprise, mobile infrastructure, cloud and data center, and in service provider. Looking at the innovation track of Cavium, which was started way back in 2001, over the period of time of 15 to 16 years, we have been addressing the disruptive nature of the industry. Way back in 2001, where industry was doing basically a single core or a two-core device, Cavium came out with the security processor, which was a 16-core SoC. Way back in 2001, people were not making a criteria on security for the network, which is becoming a prime concern today. And Cavium has developed leadership in the security front way back from 2001 till today. Similarly, in the past 2 or 3 years, we invested our engineering resources to address this industry need, specifically in the cloud and data center, by having an incubated company called Xplant, where we have our flexible switch, a device which can do 3.2 terabytes of switching. And the second one was ThunderX, which was primarily an ARM-based server, but targeting the mainstream server by itself, the E5 category of server. When the industry was going more into the microserver space, way back in 2013 and 14, Cavium started to do something differential in the industry, and that was ThunderX-based SoC. So going from Cavium to the industry by itself, the data center industry is going through a massive disruption. And this disruption is happening because of the economies which are playing into this particular segment, and also the way people are started to build the data center by itself. Way back, 10 years back, data centers were built more on the enterprise side, where it was only for enterprise consumption. But today the data centers have been architected for revenue generating model. People want optimization on the data center. They exactly know what workloads they are putting on the data center, and they are basically using data center as a mainstream business model where industries are existing just on the basis of data center by itself. Another catalyst which is affecting the data center growth is the open source forum. The sheer reason we are all over here is basically one of the factors is open source. Over here we are talking about open compute and how the infrastructure is based, but there is a whole ecosystem chain in the industry which is based on this open source environment, from the software to technologies to infrastructure hardware, where people are leveraging their engineering investments in different streams of industry and trying to basically reduce the TCO or the cost of ownership. And the reason why they are doing this is because to maximize the return on investment and to use this large pool of engineering resources or manpower for the benefit of the overall industry. What are the trends what we are seeing today? The first trend which basically we are seeing in this expansion of the data center is the growth of the data by itself. This data is basically growing in a phenomenal rate, and one of the reasons why it is growing is mobility. The tablets which are basically there, the cell phones which are there, and also more of the enterprise execution is happening in the mobile infrastructure today. People need not necessarily work from their desk or from their office, but they are basically working when they are traveling, or they are exchanging pictures when they are on vacation, or the information is being shared whenever there is a sports activity going on. So there is a huge growth in this data by itself. And people want to translate this data into revenue or in terms of an economic growth, which I call it as a digital economy. People or the venture capitalist industry is evaluating you by the content what you're having and the necessity of that content. What are you going to use this content for, and how are you going to grow this business? So it's basically a digital economy which is taking front in the past 1 or 2 years, where most of the companies today, the evaluation is not by what technology they're offering, but what amount of content they're holding and how can that content be used. With this, there was an economist way back in the 18th century called Stephen Jevons. And what Jevons basically said that when there is an improvement in technology, there would be more consumption of the technology. This goes completely against the law of economics, that if you basically have more efficiency, then your consumption will lower down. A basic example of this way back in the 1800s was the coal industry. This whole philosophy of Jevons started off when there was industrialization, and the coal industry was the main primary use of communication in terms of steam engines and industrialization. So when the coal industry improved, or the efficiency of coal burning improved, it did not have an impact that the consumption of coal reduced. In fact, the consumption of coal increased because there were more deployments of steam engines and industrialization, which was basically using coal as a part of fuel to influx this particular industry. Similarly, in the technology industry or in the processor industry, as the efficiency of the processor is increasing, the consumption of the processor is not reducing. You don't see less of the CPUs or the switches being deployed because they are going to 3.2 terabyte, or they are going into the high computing range, or when the VMs are increasing on the CPU, the growth is still phenomenally happening. And this is exactly in parallel what Jevons had predicted about the coal industry. Whenever this phenomena happens, it leads to disruptive natures in the industry, it leads to optimization, it leads to more usage model. And this particular forum is one of a prime example where it has come into place. What are the catalysts which are influencing the OCP segment to have this is basically the cloud, the workload optimization, the SDN and NFV which is happening in the infrastructure, and HPC. Few years back when OCP started, it was basically primarily focused only on the compute segment. Today we have multiple tracks in this OCP targeting HPC, targeting telco, and these are basically subsets what exactly the trends are talking about. Again, how this paradox applies to the data center architecture by itself. A classical example is traditional in the 80s and the 90s. It used to be a traditional system where there used to be an app running on one particular system, and for a differential app you would have a standalone different physical system sitting next to it. Then we came to the concept of virtualization, where there were systems and there were multiple apps running on the same system in terms of VMs. And then what we have today is basically the multi-tenant environment, where you have different operating systems sitting on a same system targeting multiple clients, and the clients are completely unaware about whether the system is owned by them, or there is a parallel client which is sitting on the same system running something which is completely differential and complex than what he's running. And each of these clients feel that they own the system, and they don't see any disparity between the operating system or the fundamental CPU horsepower given to them. Changing gears over here, let's look at the transformation what has happened in the server processor industry. Since we eventually want to talk more about the ARM servers, so I'm shifting gears over here from the economics to the trends to what is happening in the processor industry by itself. In the 70s and 80s, we used to have the mainframe eras, where people used to, or organizations used to buy expensive machines in the size of a room and keep it over there, and only one prime guy would be allowed, or the elite guy in the organization would be allowed to enter the room and start playing with that machine. It used to cost arm and a leg or the entire budget of the whole organization to purchase this type of a mainframe. Then we started off with in the 90s, we came with the client server type of a era, and also we started talking about higher CPU speeds, where people would talk about 800 megahertz, 1 gigahertz. That used to be the prime objective of CPU design. And also we looked into the multiple client environment for the servers. Way back in the 2000 time frame, we started looking into the virtualization, where there were multiple cores. We have achieved that task in the 90s of having multiple core. So now they started distributing that core to the different clients, and having the phenomena of virtualization came into play. And what we have today in the past few years is software-defined workload optimization has come into play. And the reason it's coming into play is primarily because of the cloud and the acceleration which is needed for your specific workload. And in this time frame, you see basically products which are coming out which are targeting more towards workload optimization. 5 years back when the CPUs were being launched, people didn't talk about workload optimization targeting their CPUs. So what does ThunderX brings into play over here? ThunderX is basically a best-in-class ARM CPU, what you can get in the industry today. It targets the sweet spot of an E5, 48 cores which are integrated inside one single SoC. You can have a single socket or a dual socket configuration. It supports the interconnect coherency with a CCPI interface, which is a Cavium proprietary interface. It's fully integrated in terms of the GIGI 10, 40 GIGI interfaces which are built inside the device. It supports both DDR3 and DDR4 memory controllers. It has 4 of these controllers on each SoC. And something called as a WordSock technology which is integrated inside this device. It's a Cavium proprietary technology which enables you full virtualization from the I/O to the core. And this particular family is split into 4 different segments for workload optimization. You can basically target compute, storage, networking, or security which is built inside this device. What it brings on the table is efficiency in terms of performance, latency, power, and scalability. Since you have dual socket and an integrated fabric sitting inside, the fabric is basically a standard Ethernet based fabric which is inside the device, and you get basically the best in class optimization for an ARM SoC for your specific workloads. We have different reference platforms which are available today. It's there in our Cavium booth, so feel free to stop by over there and you'll basically see different OCP platform boards which are supporting ThunderX based designs. One of the other topics which I would like to bring up is workload acceleration. This has been a key topic in the industry, and we see the industry shakers and movers merging together in terms of the CPU and the FPGA being brought into one. And the concept is today they are basically connected together on one single co-packaged or through the PCI link, and in future they'll be basically integrated inside on one single die. This is basically what the cloud servers are trending towards, or where the industry is basically looking forward. And if you look at ThunderX, what does it do? It basically has these accelerators what we are targeting to bring it into the CPU and the FPGA. This is basically existing today on a device like ThunderX. It has accelerations for your networking aspect, for your storage, for your security, and also for your compute in terms of virtualization. It is a fully virtualized SoC which is there today in production. So all of these are integrated into one single SoC, and you have basically 4 different fundamental pillars or portfolios targeting these applications. Again, in terms of value proposition, it brings you the high density to scale. It supports single and dual socket configuration. You basically get best in class TCO because of the integration from the GIGI links, from the storage, and also from the throughput what it is basically offering you for your scale out infrastructure. 10 gig, 40 gig links are enabled to the device. You do not require any external NIC components sitting on the device because all of them are built inside the device. And the last but not the least is the acceleration. One of the areas where Cavium excels is in basically in network acceleration. Leveraging on those engineering investments, those accelerators are basically integrated inside this particular SoC. Again, in terms of target workloads where this device is extremely well suited are highlighted over here. It is basically the high performance compute. It is in cloud computing, scale out storage, security, and big data. We have platforms existing today where our end customers are deploying these applications on ThunderX based servers. One of the common deployment is again big data and Hadoop, where ThunderX basically excels. And the reason why it basically does very well in this particular segment is not only because of the performance what it provides you in terms of per socket basis, but also the scale out feature in integrating of large number of disk drives onto one single SoC or in one particular sled where you have dual node configuration. Looking at the ecosystem, one part of it is the SoC which Cavium has enabled, but there is a phenomenal effort put by the industry to enable the whole ARM ecosystem. And today what we have is from an application stack, from the middleware to the OS and the firmwares which are supporting this device, and also we have a recommended component list where we are working with industry partners to be compliant in terms of the interconnects which are going onto these devices, and a breadth of ODM and OEMs who have signed up or have engaged with Cavium on building these platforms. These platforms exist in various form factors, as you can see, and they are available today through these ODM partners with which Cavium has engaged. For OCP-centric platforms, some of the partners who are demonstrating Thunder-based platforms are basically the Penguin Computing, Hive and Stack Velocity are the other two partners who have platforms today which are based out of ThunderX and are there on this floor today. There are many other ODMs apart from ones which are listed over here, since this was more centric towards OCP and this particular forum. So these are the ones who have the platforms and are been participating at this event showing these platforms. Last but not the least, the overall summary of ThunderX, what it brings on the table is high performance ARM SoC. It's fully workload optimized for your targeted workload, fully virtualized. It gives you a phenomenal advantage in terms of virtualization. We have platforms like ODP and DPDK ported on this particular platform, and we have shown demonstrations of it. It provides you with the full data security. We have the whole Nitrox engine integrated inside for your end-to-end data center security. Also in terms of power efficiency, it provides you best in class in terms of TCO analysis and scalability from a single socket to a dual socket, and leveraging the fabric for the whole rack architecture. Again, please feel free to stop by the Cavium booth. I'll be there over there to take any questions and tell you more about ThunderX. Thank you.